um, the link to the WhatsApp group that I shared in the chat. So if you're not on our WhatsApp group, you can join that. It is also so I will, after the session, yes, there are things that is loaded on my Unisa, but I'll also on our WhatsApp chat share the link to the YouTube video of a recording of tonight, and also then the presentation that I'm going through, so that you have that on hand as well. Okay, so last time we started off with topic 1. I see you guys need to do up until I think topic 2 for your next assignment, but let's see how far we get. So if we go further on to topic 3, then at least you have that already, and we can move on with it. Because I know in your last assignment, you are in any case going to need to do on everything again. So it is important that we might just need some time to do a recap and we get to the end. But also I'll work in that we try for every one of the bigger assignments that's still due. We'll do nearly a recap before that time as well. So I think your big assignment now is due on Sunday, I think. So we will make sure that we now cover everything up until then. We'll do a bit more also, and then when the next time you do have a big one also needed to be handed in, we'll just do a recap for you on that, and that is how we will continue the semester with QMI, because the QMI is a continuous program and not a subject that you write exams. We will make sure that we prepare you guys for every assignment, because every assignment is nearly vital for you to get good marks in the end of the time. Okay, so let's go into topic 2. We're going to look at functions and then nearly how to work out functions. If we get to topic 3 tonight, that will be on linear systems and equations. So basically taking topic 2 a bit further and exploring that into linear systems. So if needed, we will get to that point as well. If you are struggling to get into any of, so you're not getting the meeting invites, please send an email to the ctntut@unisa.ac.za. But when I share it on WhatsApp, you can access it there as well. And then there is some emails of me that you can also contact me. And if you later on feel that there is topics that you are struggling with, and then we can on the WhatsApp chat talk about it. If there's more than one student that's struggling with it, we can create another session. And if it's only you, you can send me a mail and we can book a session that's one-on-one, and we can do a 30-minute or hour session as a one-on-one session, and we can look at that. So that is also available, and it's part of my contract. So you guys, it's free for you guys. So if you need to have a one-on-one session, please, you can just let me know. Okay, so let's go into what we're covering tonight. So So we're basically starting off with looking at functions, what functions are. We're going to look at the linear function, and I think for your assignment, you need to just stop at linear functions for now. But we will also look at the quadratic functions because that is part of the next one that you will start to look at. And then out of the quadratic functions, we will look at exponential and logistic or logarithmic functions. So it's your normal exponential function, and your log functions is the last ones that we will look at. So again, we'll cover everything, but for your assignment that's due on Sunday, I think it is up until linear function that you need to know, and that will be the questions on that. Okay, so again, like I said last week, there is sometimes in your assignments, and yes, thanks Darby for the link on. So please just complete the attendance register while we're going through the subject matter as well. You might get theory questions, so um, just be aware of the fact that you might get theory questions, and that is why I normally share the presentation as well, so that you have it at hand by the time that you need to write the assignment. So the one that we start off with is basically what is a variable, and a variable is a symbol, or it is something that you use in a function to basically keep it open. So so if we look at something like x plus 4 will be the variable, because that is basically a placeholder for a number. We don't need to worry when we're looking at functions about what that number is. That is where we will get to when we look at the equation part. Okay, so basically a symbol is representing a number which we don't know at the moment. Then, so that might be in a theory question that they ask you what is a variable. Well, it's multiple choice, so they will not ask you what is a variable, but it might be that they tell you pick the one which is correct, or pick the one that is incorrect, and they say a variable is this, a formula is this, a function is this, and then one of it might be right. Maybe all of them are wrong, and you need to say all of the above is wrong. So it might be in a question like that. Okay, formulas is basically looking at the pure definition. Is a formula is a special type of equation which shows the relationship between two variables. So again, we will get to that, but a formula might be something like, say, x plus y is equal to 4. So it's basically showing some kind of relationship between two variables, or in this instance, two variables. It can be multiple variables as well. So when we get later on to study unit 3 or topic 3, we can get a function that or the formula that looks something like this, and then it is showing a relationship between three variables. So again, it can be wider than just one or two variables. And then functions, when the value of one variable is dependent on the value of another variable, then we say that the dependent variable is a function of the independent variable. So here, very specific when we look at, say, line graphs is a simple function. So if we have something like y is equal to 4x plus 6, so that is your simple linear function. But again, later on, we can get to quadratic functions. That might be something like this, 2x or x to the power of 2 plus x minus 6. So again, it's a function, but it is more than a simple linear function. It is a quadratic function. When we get to exponential functions, the e, that is another type of function. When we get to log, again, that is, again, a type of function. So all of these are types of functions. So again, it might be in a question that you get these four functions with another one that is just y is equal to 1. And they ask you which one is not a function. Then all of the bottom four, all of them are functions, except the one that is just y is equal to 1. Okay, so it can be something like that in another type of theoretical question that they might ask. Sorry, let's go to then what is important around the functions is, and again, I think how to look at it is, they can't ask you in any of the assignments nearly to draw a graph, because it's multiple choice, so you have to choose A, B, C, or D, or sometimes E. So they can't ask you to draw a graph, but they can ask you, if they give you a function, which of the following graphs are correct, or which one is correct. So that's why you still need to know the graphing or how to graph the functions, but you won't ever need to physically do it. And we will go through one or two examples of what they can ask you in the assignments as well. Okay, so let's move on. So here and you can write down somewhere on a piece of paper, but I'll show you what I've also done is, so we will go through a few examples, but included is also every time how to calculate it. So if we don't get to something, and I share it later on, there's actually also in there is enough, there are slides to show you how to do it. Also, if you need extra questions to work out or want to see extra examples, you can just ask me. I have some previous papers when it was still exam subject. I've got some of the previous assignment questions as well. Sometimes I don't have the answers, but we can always work that out on the WhatsApp group as well and share some of the things and answers. So let's look at the following one. The total cost in rand of renting a sailboat for n days is given by this function. So there is, in that function, we know that n is nearly the placeholder. So now they ask us, calculate the cost in rand to rent the sailboat for 1 day. Okay, so only thing that we can do is to put in 1 into the place of n, and then calculate what the total cost will be. So the only thing that we will do with this example is you have your fixed cost of 6,500, and then your variable cost is that one that's in this instance depending on for how many days you rented. So in this instance it was 1 day, so the 4125 stays exactly the same. If it was 2 days, we would have just multiplied that by 2, the same if it was 3 days, 5 days, or whatever. Okay, so in this instance, it's only 1 day, so we can, and again, you guys won't need to write it out like this, because only when you don't need to show anybody what you're doing. So you can just write the final answer, work on your calculator, the final answer, and that will be 10,625 if you add all of those together. Okay, so that will be one way of calculating this. You could also use Excel. I think I love Excel, so and what I've also seen is, so we are doing later in the subject some annuities and present functions and those kind of things. I will also show you on Excel how to use that, so that you don't need to go and buy a financial calculator unless you want to. But yeah, I think some of these calculators cost a lot. So, and in any work environment, you will probably use Excel. So let me show you how to use Excel, so that you can use those functions within Excel. So we will do that in some of the later topics that we will cover. Okay, so the next one that they ask is, so they say Nick has 55,000 cash available, and he wants to take his family on this sailing trip. How many days can he afford to rent the boat? Okay, so they basically tell us what that cost is. So they tell us that is 55. He's got 55,000. And what we then need to work out is how many days will he be able to go on this sailboat? Okay, so let's keep that as n. Okay, so the first thing that I would do is I want to get all the numbers that don't have an n with it. I'll take to the one side. So on this side, we will then have 55,000 minus 6,500. And on the other side, we will just have 4125 in. Okay, so then 55,000 minus the 6,500 gives us 48,000. So what the next step will be is that 48,500 I will divide by 4125, and that will tell me how many days they can go on the sailboat. So when I do that, I get 11 days, or actually 11,76. Okay, so basically they can go for 11 days. There's not enough for 12 days. And then depending on what the question is, there is some money left. Here they only ask, shouldn't divide it. Let me quickly see. Okay, so the one thing that in your that you had, so this amount is a fixed cost. Okay, so and that is the catch with this question, and that's why they start off with the simple one first, because the simple one is straightforward. You know it's one day, so you work out with 10, 6 to 5, but this is a once-off cost. So you're not paying it for every day that you're renting. So that is where the catch is in this question. So you and you can think about it the way, let's say it was a Avis car that you rented. So that 6,500 is nearly what you pay to get the car. And then if you, depending on how many kilometers you travel, you pay more. So that 6,500 is a fixed cost that you have to pay up front. And doesn't matter if you have a boat for one day or if you have a boat for 10 days, that fixed cost is only 6,500. So that is where the catch is in this question. You don't need to pay that 6,500 for every day. Yes. So exactly. Yeah. So and that is so what can happen now with question B is they only asked you how many days can you afford. So I would have said 11, but it can also be sometimes, and you can see with this calculation, they also get to the 11 days. Here they also worked out what amount is left. So it can be that in the when you do your assignment, they have this as a first question, they have this as a second question, and then as a third question, they can ask you how much rand is left for him to spend on something else. So that you nearly need to work out, like Carl, you now did in your way. So just don't add the 7 point or 0.76, and then you can see how much is left afterwards. So that can be nearly a third part. So you don't automatically need to do it, because if this was a multiple choice option, question B would have had, say, 10, 11, 12, 13 days would have been your options. So you wouldn't have needed to work out what the rest is. Okay, so that is nearly looking at a function. Sometimes what they say is, and where it might be that if you're doing any other decision sciences subjects, sometimes this is called your total cost function. Um, so your total cost is a fixed cost plus a variable cost. So sometimes this is nearly, if you have one of our other decision sciences, this is back basically what you have in this question, where that fixed cost doesn't matter how many days or how many weeks or whatever the variable is looking at, and then the only thing that is influenced by how long is that variable costing component. Okay, so that is one type of question. This one is now a bit different because now they're asking us, it's in a kind of word sum, and I like maths, but I'm not good at word sums, so one always need to be very careful how you look at this. See, and that is, I think, Carl, that is it. Just by phrasing it differently, it nearly seemed like this is totally new. And when you just bring it into perspective, it's okay, well, that is actually, we did it already. So a lot of the decision sciences is actually looking at the same things. We just call it different things, but it's actually looking very similar. Okay, so here they tell us a volleyball court as a rectangular shape. Okay, so remember, rectangular is something like this. We did it in theme 1 very quick because that was nearly a recap of things. Whether, and just imagine this is straight lines. So they said it has a width of x, because that needs to be the shortest one, and the length of 2x. Okay, so draw a diagram, which again you will not be able to do if you're writing online, showing the dimensions. So wonderful, we've done it. They can give you again options. So they can have something like that, where they say, well, that's x, that's x. Already it's wrong, but they can have something like that and say that's 2x, that's x. So again, you can see it is nearly out of sync with lengths. Then they can have that one, and then they can just make it a bit bigger as well and say that is 2x and that is 2x, just to nearly confuse everyone with all the numbers. So they can do something like that, and you need to pick the right diagram. Okay, so then they ask us, what is the total area? So now we need to remember, if we needed to do the, what is it, circumference, we would have said, wait, no, I nearly make the same mistake. So if we needed to say what is, if we needed to put up a fence and we needed to say what's the length of the fence that we need to get, we would have just said that plus that plus that plus that. Okay, but now we're looking for area, and the function for area is normally your length times your width, and in this instance, then it is 2x times x. And that gives us now a new function of 2x to the power of 2. Okay, so that is, so we now basically worked out what the function is. Now what they can do is say, but okay, let's add some numbers to that function. So suppose the chord has a width of 12 meters. So we now know that x is 12 and that the whole area has to be painted. So we now need to paint that whole area because it is, did they say, they said it's a volleyball court, so we need to paint the volleyball court. And they say, okay, how much will it cost to repaint the court if the cost of paint and labor is 11 Rand 75 per square meter? Sure, this is very old question because I don't know where you will pay that small amount. But okay, so we need to first work out what that total area is. Okay, so we need to work that out. We've got the formula. It is 2x to the power of 2. We know what x is, so x is 12, so we can just substitute that 12 in this formula. Okay, so then we get the total area, and that total area we are then again going to multiply by 11 Rand 75 because that is how much it costs per square meter. Okay, so let's see what the total area is. So 12 to the power of 12 is 144 times 2 is 288. So 288 square meters. And if each one of those square meters is 1175, we just multiply the two together. And then we get 3,384. Okay, that now sounds much better in terms of costing. um, 3,384. Okay, so they started off with something that looks very simple, and then they bring in another component that your function becomes a bit more difficult every time. So again, if you looked at it in this instance, you got the 2x squared that looks very simple, but then suddenly now you get to substitute, and then they give you extra information so that you need to work out what the total cost will be. So again, nearly this one was just a fixed cost, a total cost. They could have said in here something like the labor is a fixed cost, the paint is the variable cost if I wanted, or the other way around they could have said, but they bought paint for 5,000 Rand and then add a labor cost that is a variable cost to change it a bit. But in this instance, they made it that it was a variable cost dependent on how big the area was that they needed to paint. Okay, so also, again, there is some ways that they also showed how for you to calculate it, very similar to what I did, but they just add a bit more information. Okay, so let's quickly, up until this point, is some of the things coming back that you guys did in previous subjects. I think that it's sometimes one quickly forget what you did nearly in a previous subject, and it just takes one or two things and you remember it again. Okay, so that first component was looking at what a function is. They give you a bit of information so that you write your own functions. Now we're going into a linear function. So now it basically, a linear function is a straight line. We sometimes we see it in books as a straight line of y is equal to mx plus c. So that's the one that I normally like to see. Sometimes they call it ax plus b, and sometimes they use the function symbol nearly as well. So where they say it's a function of x. So they can use any of these symbols nearly in your assignments as well, and it basically means every time the same thing. Okay, so what is important in straight lines is that dependent on how a straight line look, there's always a y-intercept. So if my straight line was y is equal to 3x plus 4, that 4 would have been your y-intercept. Okay, we will do one or two examples of that, but that is what the 4 will be your y-intercept. Your x-intercept, here we can't see it, but if you had a straight line going through here, that would have been your x-intercept, and then probably here on the negative y, your y-intercept would have been. So your x-intercept is basically where it goes through the x line. How do we get that x-intercept? So it is where y is equal to 0. So a way to get that is, say this was the line. That intercept is where y is equal to 0. So we can then say, okay, well, y is equal to 0. Let's get that intercept. And then we will again use some of the algebra. That must go to that side, so it becomes minus 4. And then we will need to divide by 3. So my graph is totally wrong, but just imagine. So let's make it, let's make that. Let's make that minus. So then when we take it over, it's positive. So your x, say in this instance, is 4 over 3. Okay, so obviously it looks a bit different to that one. And then your y, we can say, goes through there where it is minus 4. So that is basically how you would look at your and calculate your y and your x intercepts. Again, they can't ask you to draw a line because but they can ask you which one is the graph. So we'll get to that. So they can ask you something like that. Then you will need to be able to work out the slope if I give you 2 points. So again, I will show you that. And I'll show you some examples of special cases if B is 0 and if A is 0. So let's just add here, when B is 0, it can also be when M is 0. And when A is 0, it can also mean that C is 0, so that you just have those options as well. So that those two are exactly the same. And those two will be exactly the same. So I'll show you some of those in some of these examples coming up. And then I'll show you when something is parallel to the X or to the Y axis. So then something parallel to the Y axis will look like that. I haven't said it here, but something parallel to the X axis will look like that. And then parallel lines, so something parallel to this line will be something like that. So we will look at examples of that because I think that is important specifically for your assignment that is due on Sunday. So let's go into a few examples. So again, this is something that they can ask is, so some of it is actually a bit of theory. So the coordinate system is divided into 4 areas called what? So if you've got 1, 2, 3, 4. So I would have said it's quadrants. If let's just see, sure, yeah, quadrants. So again, you can see my answers. We will get the answers in the next slide, but it should also be part of your study guide. You will have where they show you the coordinate system and how you can get to it. Then the next question is the coordinate system is created by the what and what axis. Okay, so they always will show you also the axis on the diagram because you guys would, so out of your ECS, you would have probably had, was price on that side? I can't even remember where price and where quantity was, and it could have been the other way around. But they needed to show you on a diagram what the 2 axes are. So here they also need to show you, because else you can work with a different set of axes. So they need to tell you it is the X and the Y axis that you work with. You can't just make the assumption, because else I can say, well, you're not telling me, so I could have worked with price and quantity. So again, yes, it's sometimes pity because your standard is normally X and Y, but being in the economic sciences and those kind of things, it could be something else as well. So they need to give you an indication of what those 2 axes are. Okay. Then they tell us, okay, the what coordinate, which is first number, tells us to go. Yo, the what coordinate, which is the first number. Okay, so I'm thinking we're talking about X and Y coordinates. So the X coordinate, which is the first number, so that is the first number, tells us to go, I would right. Yo, I will check this now. Right of the origin if it's positive, and left if it is negative. Yo, okay, this is a weird question. Yeah, okay. So right and left. Okay. This is really a strange kind of of question, but again, it can be something that they ask out of a type of theory question. So when the second number is the y coordinate, tells us to go up if we want to go positive, and then it tells us to go down if we're going into the negative space. Okay, so basically what they wanted out of this question is if you understand this whole coordinate system. So we will now, in this set, they might ask you, instead to plot it, they might give you a few points and say, is these the right ones? And then they can just say, they can maybe give you 10 plots and ask you for 5 of them that are correct or something like that. But I want us just to do a few of them so that we can get the hang of the positive and negative. So let's just take that out just in case there is numbers that needs to go there. Okay, so x is -3, so we will go to the negative side. So there's -3. Let's quickly see if, okay, I can't put my pointer on when I'm also in the draw function, which is fine. And then, so -3 up to, so that would have been my point A. Okay, -3, +2, so that would be my point A. So again, they can put points there and say which one is point A nearly. Point B, +4, so we're going to the right side. -1, so we're going down, so that is point B. And let's just do one more, and -1, so that is -1, and we stay on that line. So we're not going up to 1, we're not going down to -1, we stay on 0. So that would have been point C. If there was a point, so that point is point 0, 0. Okay, so it's not going positive or negative on the x. It's not going positive or negative on the y. It's in the middle. That's point 0, 0. Okay, so just a bit of a way of looking at your coordinate system and what might be asked around that. Okay, and here you can see there are some of the plots, so you can go and do the other three as well and check that you can do that. Okay, so here we only looked at the coordinate system. Now they're doing it a bit different. So now they're telling you, okay, here we have a straight line. Which one of these three are correct? Okay, so so let's rewrite that just a bit. So let's keep the y there. Let's rewrite it as we know, x plus 3. So that's the way we know how it is. Okay, so that is your y cutoff. So I always like to start with that, because if I look at the graphs, I see, okay, well, that is not going through 3. So this graph is wrong. Let's see. Oh, well, that is going through 4. It's not going through 3. That one is wrong. So only one that can be right is this one because it goes through 3. So just by looking at the Y cutoff, we could have eliminated 2 of the options. But let's just make sure. Okay, so how do we get the X cutoff? We know it is when Y is equal to 0. So when Y is equal to 0, we will get the X cutoff. Okay, so 0 is equal to -3 or minus X plus 3. So I want always nearly to look at X as positive. So I will take X to this side when the negative becomes positive. So X positive is equal to 3. When we look at where the X cutoff is going through, and that is going through positive. So again, that shows me I am working with the correct function. So option 3 would have been the correct one. Okay, and that is just by working through what the Y cutoff is, and then looking at what the X cutoff is, and then you have your two points. They could have added maybe, and hopefully we'll check how to work out the slope. They could have added that in somewhere, but it's very difficult to suddenly add a slope if you are actually drawing on a graph paper form like this. Okay, so this might be again something that you guys will get in the assignment, because it focuses on you knowing the Y cutoff, the X cutoff in this instance. Okay. Then the next one that is important is okay, so that is also, so there's also some explanation of how to get there. So now we doing it a bit different. So now they tell us this is your function, but you need to give a function that is parallel to this. And that function that is parallel to this also needs to go through that point. Okay, so now it becomes a bit more tricky. Then also you need to write the equation, and you will always need to write the equation into, so in this instance, they say ax plus b, but it could also be mx plus c, so whichever way. But you need to write it in a format that has a x and it has a constant, so that it is nearly in the simple format. Okay, so the first thing I would do is to rewrite this, because sure. So the first thing is I would rewrite that. So y is equal to 5 over 2x, because we are dividing by 2 every time, and then 7 over 2. So unfortunately, it's a bit stupid in how that is phrased, but yeah, we'll hopefully get to solve the answers. So if we just look at that formula, so what is your A value? Your A is 5 over 2. So again, they can ask for A, or they could have asked for M. So just if they give it to you with value of A, or if I tell you value of M, it will be 5/2, and then value of B or value of C, depending on what formula they use, will be 7/2. It might be that they want you to simplify that. So let's just see. Okay, so they wanted you to simplify that. So that you write that as 2.5, and that you write that as 3.5. Um, yeah, just again, what I normally tell the students is check what your answer set is looking like. So if they have 5/2 in the answer set, stay with 5/2. If they have the improper fractions, then try to simplify it. They will not have that as one option and the 2.5 as one option. So that you don't need to worry about. So if it is given as 5/2, your answer, you take that as correct. If they have simplified it, they would then say it is 2.5. So let nearly your answer set of things nearly decide for you what you're going to pick. Okay, so that was the first step, was to calculate the values. Then they ask us, okay, from this follows that the line has a slope of. Okay, so here, that A or that M is the slope. So that is the slope. So then the slope is basically 2.5. Let's just check if, so there is your slope. So that was your A and your B. There is your slope of 2.5. Okay, so let's just roughly, and it might be totally wrong, so I'm not putting in any numbers. So let's say that was your line. If you need to draw a line parallel to that, so that is the other line, what is this line's slope? If this slope was 1, what would this slope be? Any guesses?
Coming up dry, but not for the want of it.
Okay, go.
If that slope is 1, then the other one is 2. No, it's less. So it's got to be anything less than 1?
Okay, because you're saying that because it's lower.
Yeah, when you did you label that line number 1, or is it passing through point number 1 on the y-axis?
Okay, so let me quickly, so if it doesn't matter if that one went through 2 and that one went through 1.
Sorry, can I?
Yes.
Did you say that these lines are parallel?
Yes.
Parallel lines have the same gradient.
Awesome. Okay, so the slope is exactly the same. So I wanted, and Carl, I wanted to catch you out so that you don't need to look at that at all. So when it's parallel, the gradients or the slope will be exactly the same. Okay, so in this instance, if that slope was 1, this slope will also be 1. So when we look at this example and we said, well, that original one slope was 2.5, then any line that is parallel to that will also have a slope of 2.5. And I think that is important, nearly, Carl, what you now said, because I think one is so you look so at sometimes what's on the line and through which points it goes, because that is what they will show you as well. So they will definitely show you where it goes through the y-axis, so that you need to, they want you to think of a different answer. But the golden rule is, when the two lines are parallel, their slopes are exactly the same. Okay.
We'll not be making that mistake twice. Thank you, everybody.
Yeah, no, that's why we have these sessions. Make the mistake now, and you won't do it when you need to get the points in the assignment. So, cool. So that is, the slopes will be exactly the same. So now we have the slope of that second graph, but we don't know yet at what point it's going through. So I'm just going to take these two numbers away because that was purely guesses. So we don't know yet where it is going through, but they tell us there is at least a point that it is going through. So that's X, that is Y. So we can then put in the X and the Y into this formula, because this is our parallel formula. And then we can work out what is your C value. So when X is 0, okay, so then 2.5 times 0 will be 0. So that's actually a nice point that they're giving us. Going to be 3.5. So C is going to be 3.5. So because C is 3.5, our formula in the end will be 2.5x, because that is because the slope is exactly the same, minus 3.5. Okay. So in your assignment, they will not give you all of these nice extras added to it, because that basically gives it away. So therefore your equation is y is equal to 2.5x minus 3.5. And you can see in the end that is what it was as well. Okay, so the important one out of this is that the slopes are exactly the same when we're doing parallel. Okay. Then before we get to some of your next assignment nearly, what they can also do is actually give you something where they tell you connect what is a straight line with some of the characteristics and descriptions. It doesn't only need to be for straight lines. They can do this nearly with any one of your theoretical kind of questions. This is actually, I like these ones where you need to nearly link the two together, because again, sometimes cruel, because if you make one mistake, you're probably going to make two mistakes. So again, it is a bit cruel if you do it like this, because if I say those two connected and I've done it wrong, then one of my other connections will also be wrong. So you really need to know your stuff when they ask it in a format like this. Okay, so let's look at the ones. Two lines that are parallel So let's see, one line has a positive slope, other one has a negative slope. Okay, so we know it's not going to link to that. Two lines that are parallel. Expression is y equal to b. Okay, that is just not at all. There is no constant term. Okay, that is also not even close. Expression x equals c, where c is the intercept. Okay, also not. So it actually only leaves that one, but both lines have the same slope. Okay, so that is actually, we did it just now. So one goes with E. Okay, two lines that are parallel, both lines have the same slope. Okay, so we take that one out of the equation. Okay, then a straight line that passes through the origin. So let's look, so that is the origin. So it can be a straight line like that. It can be something else as well, but one line has a positive slope while the other, okay, so still not A. Expression is y equal to b, where b is the intercept on the y-axis. No, because it actually goes through the intercept. There is no constant term b in the equation. Okay, that is quite interesting. So where is it going through? It is going through 0. So your y-intercept is 0. What is your y-intercept? It's also equal to your b value. So if we go back to, and that, while you're doing your assignments, keep these, I'll share it afterwards, but keep it with you, because now sometimes one miss it, but that b was the c intercept. Okay, so that b is where it goes through your y-axis. So keep these notes, because keep it next to you, so that, because I would not, my mind works it out, and you can see here now they talk about C, so my mind is nearly, I work always in the y is equal to mx plus c kind of way, and not the ax plus b. So just that you know the other format as well. Because it might be also that they use it interchangeably in the assignment. So this one will be, your second answer will be C, because it goes through the origin, so it is 0. Okay, so we've taken out that. Okay, so let's look, a line that is parallel to the x-axis. Okay, I nearly want to go there, but let's not. One line has a positive slope while the other has negative. Okay, no, so let's just in this draw. So something that is parallel to the x, okay, that's parallel to y, so sorry. The parallel to x-axis is all there, or it is that one. So those two are parallel to your x-axis. So let's see. So expression is y equal to b, where b is the intercept on the y-axis. And again, your y is your b value. They tell us that. So there you can see it goes through the intercept. So it goes through, if your y is positive, it will go up there. If it's negative, it will go down there. So it is option B. What sometimes help as well is keep a notepad with you when you're doing these questions, and just quickly draw a diagram of nearly the word so that you can see what you actually need to find. That is also sometimes a bit easier, is to actually when you draw just a small diagram. Again, for me, it's easier to see it that way, because sometimes the long wording and sentences does confuse one a bit. Okay, two lines that intercept at the origin. Okay, two lines that intercept. Two lines that intercept at the origin. So is that two lines that intercept at the origin? So that's one line, that's the second line, and it goes straight through the middle. So one line has a positive slope, yes, while the other has a negative slope, yes. With both b's equal to 0, yes, because it goes through there. Okay, so that can be A. So let's say it's A. And then we just look at what is your last one? A line parallel to the y-axis. The expression x is equal to c, where c is the intercept. So again, basically doing the opposite of what was done with option 3, where that expression y equal to b, where b is the intercept. Here we're looking at expression where x is equal to c and c is the intercept. So option or question 5 was option D and not B. Okay, so this basically can be a way that they can ask you how to look at the types of straight lines and then some characteristics that goes with it. And again, it's not always straightforward, because I must say you need to go nearly back to, where was it? Back to this to nearly remember. Okay, parallel lines, the slope is the same. Okay, so then that happens if B is that. Okay, then that happens if C is that, then that happens. So it's nearly keeping the characteristics of linear equations close by and then answering something like this. Okay, so that is the, if I've got it right, what you need to know for your assignment that you need to hand in on Sunday. But let's look at a bit further. What I will do, so again, let me just share the link to the WhatsApp chat. So anybody that still wants to join it, please join our WhatsApp group. What I will do is, for everybody new that joined, later tonight I'll post again the first presentation and now this one. And I will also share both the first session that we did and this session. So if you need to go back and relook maybe some of the first topic, I will share that session that we had as well, and the presentations. Okay, so from straight line, and we've got 16 minutes left, so let's use that to just start a bit with quadratic functions. So in the simple regression, we had this straight line function, the mx plus c. So now that becomes, they add one extra thing, which is a quadratic. Okay, so now instead of just one variable, now it becomes two variables. Okay, so that is also sometimes why it's easier to use the A and things like that. So now it becomes A to the power of plus bx plus c. Okay. I kept the c the same because here, as in your linear equation, c will once again show you where the cutoff is through your y-axis. So if that is your quadratic, that will be your c value. If that is your quadratic, that will be your c value. So so again, like in the linear, in your quadratic, c is also the cutoff at your y-axis. So that is nearly to keep it the same for you guys, so that it doesn't matter what type of function you see, the c will always be the one that is the y-intercept, where it is the cutoff. The other thing that I want to, so you can see the shape, and they call this quadratic, I think, what's it, a parabola. So it looks exactly the same one side, so, and then the next side, so it looks exactly the same. When your arms is going up, whatever is in front of that A will be a positive. So you will see that your A is always positive when the arms is up. When the arms is down, that A will be negative. Okay, so again, if you need to identify a graph, like we needed to identify in one of those examples, the free graphs, if you need to identify again something, and let's just quickly do this. So let me write and it might not even, so please don't go and calculate this. Oh, that's actually quite cool. The smiley face. So that's actually quite a nice one. So if you're happy, it goes up. If you're sad, it goes down. That's actually cool. Oh, okay, that's actually quite nice. Never thought about it that way. That's actually quite a nice one to remember. Thanks for that, LZ. I think that is awesome. So that you will now never forget. I think that's brilliant. I will remember that now as well. That's an awesome one. So in this, so we're unhappy. So if you had, say, 4 examples that you now need to choose from. So say that one was that. Here we have one that's going down. And you can see I'm just rough making this. So by just looking, okay, so we're unhappy. So it's or that one, not this, not that. Then we look at, oh, there's the y cutoff. Oh, that y cutoff is probably +6. Ah, there's one that's negative. So let's say that's -6. And there you have it. Without going into much detail yet of how we calculate it, by just some simple, yes, I like this. Looks very much like a smiley face, and that you can even see as, cool. I will not forget this, thanks. Okay, so that is nearly the shape of a graph where we identify the A. Then you can all see that what happens on this side is exactly the same on the other side. So that's what they talk about, the symmetry of a parabola. Yes, it can move. It doesn't all need to go through the origin. It can move around, but still, if it moves to that point, and say that was the graph, it will still look exactly the same on both. So now your symmetry will just move with your graph, but it will still be in symmetry. The other thing that they give us is the turning point. So that turning point that is there, or is someplace there, there's a formula how to work it out, and that formula is x is equal to minus b over 2a. Okay, it's always like that. That is always your formula for the turning point. Doesn't matter if it is going up or if it's going down. That is your formula. So that is one that you need to remember. So again, don't go and study it. We have it on the slide. So you just need to remember that is the turning point. Okay, and then the intercept on the y-axis is the easy one. We just read it off from C. The intercept on the x-axis is a bit more difficult. Okay, so again, please don't go and try to study the formula or even know why it's like that. We just going to use it. So whatever was your b value, we can just slot it in. Whatever is your a value, we can just slot it in. Whatever is your c value, we will just slot it in so that you get the two cutoffs. So in this instance, there wasn't any x cutoffs because it needs, for x cutoff, it needs to go through the x-axis. So there it would have been 0. So whenever we put in those B and A's and things like that, we will not get any answer. And most likely because the function underneath that might even be negative or something like that, but we will not get answers because with this instance, it doesn't go through your x-axis. The same with this one. Actually, it also didn't go through your x-axis, so there also would not have been anything that we can work out for your x-axis. If I look at this one, that one would have had something. Again, this one wouldn't have had, that would have had, and that one. So depending on how your graph looks like, it might have a x-axis cutoff or not. Okay, so that is, I think, where we're gonna stop tonight. I'm in any case going to share the rest of the presentation as well, because that is your next. So we were very close to going into linear equations and those kind of things, but let's not, I think, let's stop where we are, that you don't need to worry about the rest, and we can look at that next week, so that we prepare for your next assignment nearly in time for, I think when I looked at your timetable, it looks like you now need to nearly is it every Sunday that you guys nearly need to hand in something?
Yep, every Sunday.
Yeah, every Sunday. So also weird why it's a Sunday and not a Monday, but so next week we will just continue so that again, you have enough time to then complete the next. I think the next one after this Sunday is again like a 5% and one or two or three 5%ers and then a big one again, and then a few 5%ers and then two big ones. So we will work towards those times that we just get alignment. So next week we will just continue up until where we need to, and we will continue like that so that you get enough prep every time before you need to hand in an assignment. Okay, great everyone. Have a good evening. I'm stopping the recording. I will definitely put it onto YouTube and share the links with you guys in the